Train car A has mass 25,000 kilograms and initial velocity 5 meters per second to the right. Car B, with mass 15,000 kilograms, is initially at rest. The cars collide and couple. Find the velocity at which the cars move off together. So you can see on the left, this is before the collision, and then on the right, this is after the collision. Before the collision, you can see that car A is in motion and car B is not. At the end, cars A and B are stuck together and they are moving along the tracks at a common speed. That represents the initial momentum, and that represents the final momentum. The momentum initially and the momentum at the end should equal each other. Car B has no momentum initially because it's not moving. Momentum is mass times velocity, and if the velocity is 0, then obviously that mass doesn't have any momentum. So the entire momentum of the system is accounted for with car A. The mass of car A times the velocity of car A. At the end, these two masses are coupled together. Car A has a mass of 25,000 kilograms. Car B has a mass of 15,000. They're stuck together. So the sum, the total mass that's moving, is 40,000 kilograms, and it's moving with some unknown speed, which is what we're asked to find. And those two need to be equal to each other. So this is a fairly easy problem. We're just going to divide both sides by 40,000, and that'll tell us the velocity of the combined cars A and B, 3.1 meters per second to the right. Is kinetic energy conserved when those two train cars collide? That's kind of a silly question. Answer number 1 is no. Mechanical energy isn't conserved for perfectly inelastic collisions. You'll recall that a perfectly inelastic collision is one in which the objects stick together. And we talked in a previous lesson that any time you have a perfectly inelastic collision, kinetic energy, that is mechanical energy, is not conserved. Why don't you show me that? Here's the initial kinetic energy. Recall that at the beginning, only car A is moving. Car A has a mass of 25,000 kilograms and is moving with a speed of 5 meters per second. Car B is not moving, so it doesn't have any kinetic energy. The formula for kinetic energy is 1/2 times m times v squared. So there are those terms. 1/2 times m times v squared comes out to this number, 3.1 times 10 to the 5th joules. At the end, the masses are coupled together. We talked about how that entire mass of 40,000 kilograms is moving at a velocity of 3.1 meters per second, which we found using the conservation of momentum. So the kinetic energy of the system at the end is 1/2 times the mass that's moving times how fast it's moving squared. And that comes out to be, sure enough, less than the kinetic energy we had to start with. How much energy was lost as heat and or used to deform the coupling mechanism? It's simply going to be the difference between these two. The energy that is lost, and again, lost is in quotes because it doesn't disappear, it's just turned into heat. 1.2 times 10 to the 5th joules.